With ads. And when you break the config, the entire thing dies. That's really cool. Yeah.
All right. I should be worried about moving the microphone across, but here we are. Nothing's broken, nothing's short-circuited. We're doing well. Okay. How is everyone going today? I'm very hesitant. I keep thinking something's going to break, but everything is okay. This room is better than the other one. We're never going back to that one again. Okay, so yeah, welcome to week 8, Wednesday. Amazing. So next Monday, we're going to go do the same thing. We're going to go into the seminar room in K17 because that's not going to break. And we're going to lower the screen. I'll be across and we're going to do a big lecture program. We just had a small argument because apparently no one knows what the World Cup is. So I guess that's that. Ben is winning that argument. He was doing a poll. And okay, so that's next week. But this week, we're just going to continue going with linked lists. Just please hold your excitement. I know it's beyond. Everyone must be super pumped. Linked lists is the way to go. Sometimes, not always. Sometimes arrays is the way to go, and sometimes other data structures. So last week, not last week, just last time on Monday, which I really would rather forget, we deleted from a linked list. So we went through, we talked about all the different cases. So what happens if it's an empty list? What happens if you're deleting at the head, at the tail, in the middle? What happens if you haven't found the item that you want to delete? And we're going to recap that today as well. And today, because we deleted, we were deleting based on what the data is. So we were matching the data and then deleting. So today I thought maybe we'll delete a position. Why not? The world is our oyster. Okay, so we'll recap deleting again. We'll talk about leak checking, which is just checking that you've freed all the memory that you've mallocked. Something exciting as well. We're going to do some linked list problems because that's the best way to learn about linked lists is to kind of work through it. And some of the problems that I came up with is delete at the nth position, find and print out all the even numbers in a list, and perhaps insert nodes in like sequence in order in a list. And if you want to do anything else, if you come up with a question, you just throw it at me. Maybe not today, but we'll do it next week. And then I don't know if you've noticed, but our linked list.c file is becoming a little bit of a dog's breakfast. It's becoming quite unruly. There's a lot of functions and there's a lot happening, not that pleasant. So we're going to also talk about multi-file projects, which is splitting up our code into multiple files as well to make modular code. All right, where's the code? Tom will paste that in the slide. The lecture slides, they should be there. I have been promised. Ben is giving me the thumbs up.
Yep.
I put them there yesterday.
Yep, that'll be there soon.
right? Okay, okay, all right. And let's do a little recap whilst we go. Okay, so deleting a node, inserting a node, doing anything with your nodes. In all instances, we sort of follow a very similar structure of what to do, you know, when we delete a node or when we insert a node. Every time, please, 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 as for your assignment, draw a diagram, because it's really one of the only ways to really understand what's going on, and also to really kind of get the logic down pat of where the next is and where the previous one is and who you need to connect to what and where you need to go, so that you don't kind of end up with, you know, connections everywhere. So to delete a node, find the previous node to the one that's being deleted, change the next of the previous, and free the node that's to be deleted, and then consider the possible edge cases. I cannot say that enough. Please make sure that you consider all the possibilities, and the few that you can kind of always kind of have at the top of your mind is what happens if you try to delete with nothing in the list. What happens if you delete when there's only one item in the list, and that's deleting the head then. So what happens when you delete at the head? Deleting the head of the list, deleting the tail of the list, and try the different combinations that, you know, that are potentially happening. Okay, let's do a problem so that we can kind of practice and get a bit of a feel for it. So I'm saying delete at the nth, well, I'm not saying, let's do the problem of delete at the nth position of a linked list. And we did insert at the nth position, so this will be similar, except this time we're getting rid of a node. So the user will be given the position at which to delete, and they will be given the list, and then they will need to remove the node at that position from the specified linked list. So for example, if your list is 3, 4, 5, 6 null, and we're deleting at position 3, we're going to delete the third node. I'm making it tricky and not counting from 0. I'm counting from 1, if you've noticed. So 1, 2, and 3. And so we're deleting the node with 5 on it. And that means our list will become 3, 4, 6, and then onwards to null. So let's try and do that in a drawing, or maybe we'll try and do it in the code, and then we'll go to the drawing. Okay. So first of all, we need a prototype for this function, and the comment really should be where the function is, but because I'm doing, okay, I'll go down to do a function. You can see definitely becoming very unruly here. I'll go to the end. Okay, so still the same, we're still just working in the same file. Okay, so we've got a function to delete at the nth node of the list. What will be the input to this function, and what will be the output? So first, let's do the input. What do you think you need to give this type of function? It's a good question. For the counting of the elements of the linked list, why does it start from 1, not 0? You know what? It doesn't actually. It's just that's what it does in my head. So we start counting at 1. But your question will specify at which position it is. So you will see whether you need to start counting at 0 or 1. But for me, I just, yeah, don't like starting at 0. It's a node. It's a physical thing. It's there. It's the first node. It exists. So we want the head and the position that we want to delete at. So we're going to give, our input is going to be head of the list, and also the position at which to delete. Okay, and then what will be the output out of this list? What do we reckon? What will I return out of this list? What do we reckon? What are we going to return out of a list? That is going to delete a node. What will I return back to the main function so I have access to this list again? Yeah, the linked list items. And how can I return the linked list items? What is the one thing that sets me on the scavenger hunt of the linked list? Yeah, so the head. Perfect. So once I return the head, then I'll be able to work through my linked lists, and hopefully that deleted node is going to be out of it. So we are returning a head of the list. So it's going to be a pointer to a struct node. And let's call our function delete node at, oh, horrible. I don't really like it. That's a very long name. I'm just going to get rid of it. Oh, you know what? That's not that much shorter. I've won 3 letters. Excellent. Okay, and then the input is a struct node head, and also I'm giving it the position at which to delete. Okay, fantastic. So let's, I guess the first things that we always seem to do in a linked list is we keep track of where we're at. So let's do a struct node current, and we'll set it to the head, and that will tell us where we are at in the list, and we can use it to move through the list. And because we're deleting, perhaps we want to also keep track of a previous node. So in this case, let's keep track of the previous node. And if my current node is sitting at head, that means the previous node is sitting before it. So it's sitting at nothing. So it's sitting at null. So this means that I've initialized both of these. My current address is at the head address and my previous is at the null address. And now what do we think I would need to do? What do we reckon? So what do we reckon I would need to do to get to the position that I delete from? What else would I need to do to be able to kind of, can I just go, okay, delete at position and then just specify the position in a linked list like I would in an array, you know, delete whatever's sitting inside array 5. Can I do that? What do we reckon? Yeah. Yeah, Nicole in the chat, definitely. Use a while loop that stops before the nth position, absolutely. And I need to have a counter that counts me out. So when I have a linked list, I don't know, I can't, it's not an indexing data structure. I can't just index to a particular place. I only know what happens. Each node will lead me to the next one. And that's as much as I know is where the next node is sitting. Well, in this case, I also know where the previous node is sitting because I'm keeping track of it. So to get to the position, I will also need a counter that will count me up to the position that I want to delete at. Okay, so let's draw a diagram so that we can see exactly what we're trying to do. Okay, so let's say I've got a linked list, and the linked list inside it has amazing. What a list. Okay, so I've got a list of 3, 4, 5, 6. Actually, that's going to be a null because I don't. Okay, and then somewhere here, I'll also have a head pointer that will point me to that first node. Okay, so I've said that this is also my current, which means my current is over here. And my previous, I've said it's going to be equal to null. So currently it's equal to null. Okay, and let's say that I go to this function, and you can't see what I'm writing because I'm slightly lower. There we go. So delete at position, and I'm going to give it the head, and also I'm going to give it the position at which I want to delete. Let's just do position 3. Okay, if I wanted to delete at position 3, it means that I want to be deleting this node over here. So if I travel to this position, so if I go here and then here, and I go to this position at position 3, what happens is I will not know, if I delete this node, I will not know how to connect because I've lost count of the previous, unless I keep track of the previous in my previous pointer, which is what I'm doing. So if I get up to this node here that I want to delete at third position, what happens then is this will be my previous, and this will be my current at that position. So if I delete this node, I'll want to connect my previous to the one that happens current next. So I need something to keep track of which position I'm at, and that would be a good candidate for a counter. So let's have an int counter. And what do you reckon, we'll set it to 1 or to 0? What do I reckon? 1 or 0? Just had a nice discussion about being, yeah. Okay, so we'll start counting at 1. Because that will mean that this is the first node, this is the second node, this is the third node. Okay, excellent. So now I'm going to have to pulse my way through the list because I really want to be able to move my current over. So what do you think, and everyone has been correct, I will need a while loop, but what do we think will be the condition inside my while loop that will keep me moving along? What do you reckon will be the condition? What do we think? It's always a very similar condition. You really have a few choices. Yeah, so whilst current is not equal to null, that sounds good. So whilst current is not equal to null, so that will keep me going until my current is sitting over here, so at null. You did not see what I just drew. That means that outside this loop, when I come out, if my condition is while current is not equal to null, that means when I get to this point, your current is going to be equal to null, okay? So you've gone through every single node of the list and you've gotten right to the very end. Okay, and is that going to be the only condition I'm going to keep? What will I do inside here then? What do we reckon? Yeah, we want to increase the counter at some stage. We do. We also want to move things along, don't we? So whilst but we want to do something at a certain position. So how do we know that we've reached that position? Yeah, so we want to, very good. So we want to combine this statement with also checking whether the counter is going to be less than the position. So whilst it's less than the position that I want to delete at, I want to keep going. Okay, so then when I get to this point, either the current is equal to null or my counter is equal to or greater than the position that I want to delete at. Don't know. Okay, good. I see a few things in the chat that are working well. Okay, so this will keep me moving along until either one of these conditions. So it will keep me moving along. It will make sure that I don't go off the edge of the list as well. So that means now I need to increment a few things. So whilst I'm moving along, I'm going to say that previous is equal to current, which moves my previous node up. And then I'm going to move my current as well. So current is going to be current next, which moves my current pointer out. And then, as everyone has said, I also need to increase my counter so that I can keep counting up to the right position. Okay, so when I get to this point, either I've gotten to the end of the list and nothing has happened, I haven't found this position, or my counter is perhaps equal to this position or greater than this position. So there's two options, which means that I really need to check that I am in the right place and I'm exiting out for the right reason. So if my counter is equal to position after I exit out, and there's a few other things that we'll need to think about here, but we'll just do the code first for the delete, then what are we going to do? So if it's equal to the position, then I want to actually do my deleting, don't I? This is when this is where the magic happens. This is where I cross out that node that I don't want. And yeah, so people are already posting in the chat. Okay, so when I get to this position, no, that's not what I meant to do. I meant to go to here. So when I get to this position, this means that I am actually standing in that piece of code. I'm standing over here and I'm saying my current Let's run through it. Always get it. Okay. So if I were to run through this piece of code to see what happens and what I need to do, okay, and this is my list. I've got my counter is equal to 1. So I've got my previous is equal to null and counter is equal to 1. Okay, whilst current is not equal to null and counter is less than position. So I'll go in here. This is my current over here right now. And if that's my current, then it's definitely not equal to null. So that's true because it's got a node there. And then my other checking is if the counter is less than the position. Position over here is 3 and my counter is 1. So the condition I'm checking is 1 less than 3. Yes, it is, which means that I go into this while condition and I'll say previous is equal to current, which means that this now becomes my previous. And my current moves along by 1. So the current is now over here. Excellent, and the counter is increased by 1, so it becomes 2. So then I go in the while condition again and I'll check, is the current not equal to null? It's not equal to null, so that's perfect. And is the counter, so is 2 less than 3? Yep. So I'll go back into this loop and I'll say, okay, that means now previous is equal to current, so I'll move my previous along. And then I'll move my current to current next. So I'll move my current along and I'll increment the counter. Okay, I'll check again. Is the current not equal to null? It's not. Fantastic. That means I'm not at the end of the list. And that means that now I check for my, so is 3 less than 3? No, it's not. So that means I come out of this while condition. So now I'm outside it. And so now what I'm going to do is I'm going to check whether or not this is the condition that I exited out of the while statement for. Because if it is, so if counter is equal to position, so if this 3 is equal to 3, that's when I actually want to delete. So if my 3 is equal to 3, so if the counter is equal to the position, then I want to start deleting. I'm sitting over here. This is my previous, and that's my current. So I'll just erase these so that it's a little bit more clear. Okay, so the previous is this one and the current is this one. What should I do first to link it up? So I want to be able to get rid of this node and I want this node to take me to this node. What do we reckon I'm going to need to do? Where do I change that? Yeah, so someone in the chat, I can see it. So previous next, so the address of my previous, I want it to be pointing to whatever is sitting in here to current next, because that will link up my nodes the way I want them to be linked up. So that means my previous next is going to be equal to my current next, okay? And then I am ready to kind of make the magic happen. So after I've done that, I'm ready to free my current. And what that does is it kills that node. It frees the memory that was allocated for it. So you free that, so you get rid of it. And then since you've deleted, you now want to exit out of this situation so that you don't just keep going through this piece of code and deleting more things. So then you will just return head because you've done what you wanted to do. Okay, excellent. Okay, so let's see when this situation might break, because we haven't really considered any edge cases at all right now. So let's compile it. Okay, we've got a statement, does not return a value. Okay, so that's kind of having to do with this, and I don't have a prototype for it as well, I've realized. So I'm just going to copy this across to be a prototype. Okay. And really wish this screen was bigger. It's doing my head in. Okay, and then I'll return head at the end because otherwise I'm only returning something in one place and it's inside an if statement. So what happens if I don't go into that if statement and I've said that my function is actually going to return something? It means I've lied. Okay, so let's run it. And what have we, oh, I forgot to actually call this function. Again, the usual story. Okay, so my list is 5, 4, 3, 13, 8. What position should we delete at? Let's delete at position, let's delete in the middle because that's usually the case that works whatever you do. Well, not whatever you do, definitely not. So let's delete in the middle. So I'll say head is equal to delete node at position, and then I'll give it the head, and I'll also say to delete at position 1, 2, 3. I'll delete at the third position. And then I'm going to print the linked list again so that I can see what actually happened. Okay, let's see if all works or if it breaks. Okay, so it was meant to delete at the third position. And what was at the third position? So we've got 5, 4, 3, 13, 8. I wanted it to delete 3, and it did. Amazing. So it works to delete in the middle. Ah, I understand. How's that?
Yeah, it's much better.
Okay. Ah, can't see. Sorry, apologies. Thank you, Tom. Okay, excellent. So, you know, most of the time you're like, look at this, things are working. I'm, you know, a God amongst men. I'm amazing. And you've forgotten to check any of the edge cases that will actually potentially break it. So this is where you really need to check for your conditions. Let's see what the conditions are. I'm just going to comment them in the code down here. So have you checked deleting at the head? Have you checked deleting an empty list? Have you checked, oh, don't want that to be in the piece of code. Have you checked deleting at the tail? Okay, let's check all of those things. So now I'm going to delete at position 1 and see if that works. So I'll go back to my main and I'll modify it to delete at position 1 because that will be deleting the head. Here we go, delete. So deleting at position 1. Let's save that and let's run that again. So compile, run. Okay, I've broken it obviously because it broke, right? Because of this previous next situation. If I'm deleting at the head, what happens is that this is going to be my current. If I'm deleting at the head, this is going to be the current. That means the previous is sitting over here and it's equal to null. So when I try to go into previous next, what happens is I'm trying to dereference a null pointer. And that's going to break my code, which is what usually happens when it all goes to, you know, that's it. Yeah. So what's going on? Let's take care of this case. So what happens if I have to delete at position 1? What happens if I have to delete at the, you know, actual position that is going to cause me to delete ahead? How will I check for this? Actually, there we go. How do I check for this condition? And there's a few ways to do it. What do we reckon? Yeah, I can check if current is equal to, well, I can check if current is equal to head. Well, it is because I've set it to that. But you're right, I can check for it afterwards as well. I can also check if my previous is equal to null and then, you know, counter for that. So there's a few different ways to do it. So if we go down, and I might do it with the previous now. So where is this? Here it is. Okay. So over here, before I do if counter is equal to position, I'm going to check whether my previous is equal to null. So if my previous is equal to null, which means that I'm sitting right at the very front before it even started. Okay, and if it's equal to null, then what I'm going to do is I'm going to say that my head is going to be current next, or just, does that make sense? So if my previous is equal to null, that doesn't make sense. Who let me put this in? Okay, so if I'm deleting at this position over here, and this is previous over here, previous is equal to null, then what will I return? Or what will I do? What do we reckon? Anyone? No one likes this previous, I think. Okay. What if I do it differently? Yeah, so if you're saying head is equal to current next, okay. The other way, I can check for it at the start as well. I can check if I want to delete at the start. So I can check over here straight away before I even go into the while loop if my current data, that's not what I want, is it? If my counter is equal to position. And that means this is the very first thing that I'm going to delete. Yeah, so that's the other way I can do it. But I still have to delete, so yeah, so you can return null because you're going to be, but you might not be returning null. It might just be, you might be just deleting the first node and there is, there's still more things going on. So if you return null, you're going to lose track of the list. So if you want to remember how we did it before, I'm just going to go up a little bit to, maybe I'll find this function that we did before. Here it is. So when we were deleting at the head, we said if current data is equal to data, we said head is going to be current next. We're going to free the current and return the head. So what we did, and we're going to do something that is very, very similar here, is if counter is equal to position, which means we want to delete the head here, what we're going to do is we're going to move it along. So we're going to move the head to the next one, to the current next. So the head is going to be current next, which means that we've moved the head along to be now, you can't see what I'm drawing, I'm sorry. There we go. So now we've moved the head to be pointing to this one down here, to the one that used to be previous. And now we want to free whatever was over here so that we can get rid of that head node. So we're going to free the current. And we're going to return the head. Okay, let's try seeing if that's going to work for us. Okay, and so the list before used to be 5, 4, 3, 13, 8, and now it's 4, 3, 13, 8. So we've captured deleting at the head. Let's try deleting at the tail. So our list is, and then we'll do an empty list. So 1, 2, 3, 4, 5. So at position 5. And then you can tell me perhaps how else I can break it. There are other ways I can break it. Okay, so let's delete at position 5. And then Tom, if you could please run a poll as well. Thank you. So let's run it. Okay, the tail deleted, no problem. So that was all good. So we've captured that. So now how else can I break it? What do we reckon? There is a few more ways I can break it. One of them was actually given in the chat. I'll do it now. What happens if position is given as 0? What happens if I give it 0? Okay, well, nothing's happened. I haven't deleted anything because I'm not really counting it. What else is going to position greater than length? Yes, absolutely. What happens if I give it position 6, which is greater than how many items I have? Is this going to break it? Is this going to potentially... Okay, yep, so that's going to break it because it's going to keep counting up to 6, and when it comes out, it's going to be pretty unhappy about it because there is no item 6. So that's definitely something that we would want to kind of, you know, counter for. So we'd need to check that. And one more thing, I really wanted to do an empty list. So let's say my list is going to be here. I'm going to get rid of everything that puts things into a list. And it's going to be an empty list. Do you reckon it's going to work or it's going to fail? What do we reckon? Oh, nice. It's just returned a null for me. And why did it return a null for me? Because the list is just null. So it hasn't really complained too much, which is bizarre because I actually haven't called the function. It should have complained. I must have got it. It's really hard on the one screen to see that. Is everyone getting really just a bit frazzled with me scrolling up and down tiny chunks of code? I just want to extend this screen a little bit. Okay. Okay. Yeah, so all of that is equal to null. Counters is save counter. No, it's going to go in here. Whilst current is not equal to null, so it's not going to go in here. So that means outside of here, counter is going to be, it's going to be equal to null. That's not going to, and then it's just going to return head. So it's captured it here. Okay, how are we all, okay, waiting for the diagram. I was just about to say, should we do a diagram? There we go, perfect. Okay, so let's have a look at where it's capturing it. I'll show you. So let's say I've got an empty list and I'm just going to delete the extra things so that, let's go to here. Let me erase a little bit of this so that it doesn't look as horrific. Well, no, counter is not equal to position because I've got position as 6. So let's quickly have a look at what we're doing. So I've sent it off into the world to do its thing. I've given it, there is nothing there. So my list has currently got nothing at null. And I've said to it, delete node at, and I've given it the head, and I've given it position 6. Okay, so let's go down to my function. That's the wrong way. And let's run through it to see how it's doing it. Okay, so I've got my list is just literally null because it's an empty list. There's nothing there. And so my head is equal to the null, and I've got my current is equal to null as well, and my previous is also equal to null. Okay, and the list is just this. Okay, my counter is equal to 1. Exciting stuff. And now I can maneuver down. Okay, if counter is equal to position. Okay, my position is 6 over here. My counter is equal to 1. Is 1 equal to 6? No, it's not. So I'm going to skip this if statement. and I'm going to go down to line 221 to go to the while statement. Okay, now my while statement is saying whilst current is not equal to null. But in my case, current is equal to null, which means I'm going to come out over here and I'm going to get over here. Okay, great. So my current is equal to null at this point. I'm really over here at this point in time. I'm checking again if counter is equal to position, but counter is not equal to position. 1 does not equal to 6. So I skip this statement altogether. And when I get to here, what I do is I return head. And my head is equal to null, which means that I return null out to the world. Okay, and then, oh, God, excellent. Now, what happens if my position is equal to 1? Because then over here, I'm going to go into this situation over here, and it's going to be a little bit of a problem, isn't it? Absolutely, that is excellent. Look at you picking up all these horrible edge cases. Well done. Okay, so if my counter is equal to 1, then it's not going to like it very much because I'm going to try and dereference a null pointer. Okay, so again, I've dereferenced a null pointer, and that's because down here, when it's all equal to null, excellent, I'm actually, this statement is going to be true because 1 is equal to 1. So I'm going to say head is equal to current next, but there is nothing in current next because it's equal to null. So it's going to break me, just like linked lists sometimes break me also. So you can just take care of this, right? You can just say, okay, if current is equal to null, then I'm going to just return, I don't know, you can return the head or you can return null, whatever you want, or you can, right? So you can return anything that will give you that null. Okay, so now it should not break me. And now it doesn't break me. So I've kind of taken care of that as well. Okay, Tom is, yep, Tom, yep, thank you. Oh, 16% of people feel great, but there's only 32 people that have taken this vote. So this is not inspiring a lot of confidence in me. Hey?
60 people watching.
Okay, great. Others are just staring at the screen thinking, WT. Okay, all right, let's try something. How about we try like something really simple? Because so inserting and deleting are the hard parts because you have to make a node, so you've got to call memory, or you've got to free a node, which means you've got to free memory. How about we try just a simple list traversal, the second problem that I had. And the second problem that I had for us to practice is just to traverse a list nicely. Similar to what you would have to do in a question 2 of an exam, you just traverse it. Question 4 is where you'd have to do some more magic. So let's say I want to have a function that prints out all the even numbers in the linked list. Okay, what do we think would be the input to this function, and what do we think would be the output? What do we reckon? I just heard like a little click and I thought the screens have gone off. I'm very paranoid. What do we reckon will be the input into this? Yeah, so, okay. So to input, we've got to give it the head so it knows how to get through the list to check for things, and the output is going to be void because I'm printing stuff out. So I'm going to void, or even voif, I'm going to void, and I'm going to call it find even, and I'm going to give it a struct node head to work with. Excellent. Okay, just, you know, my natural standard start, I'm going to give it a struct node current is equal to head. So that will allow me to traverse through my list to find those nodes. So what it means that I want to do is I want to be able to, if I have a list that looks like this, I want to be able to print this one and this one. So I want to be able to traverse through this list, so to move through it, and each time I get to a node, I want to check if it's even, and then if it is, I want to print it out. So I want to move through the list. Every time I get to an even data, print it out. Okay, if I need to move through the list, that means I need to traverse the list, which means that I'm going to have a while, which allows me to traverse this list. Now, in my while statement, will I need to go all the way to the end of the list, or will I stop at the last node? So should I go all the way until I'm at null? So that means I've gone to every single node in the list, or do you think I should stop at this last node here where the 6 is? What do we reckon? Do I want to visit every node, or do I want to ignore the last node? Okay, so we've got a few people want to stop before null. Should we try it? It's the only person that has. Anyone else have differing opinions? Okay, a few people want to ignore the last node. Okay, let's see what is going to happen if we stop before the null. So current next is not equal to null, which will stop me at the last node. It won't have me going to the end. Okay, and let me also fill up my list so that it looks like what I wanted. Actually, we're just going to do it in code. Okay, and then I'm going to check if it is an even node. So if my current data, so the data that's sitting inside there, how will I check if something is even? Back to week 2. Yeah, okay, modulus 2. So if that's equal to 0, which means that there is no remainders when I divide by 2, that means I am winning at life, and I'm going to print out this node. So I'm going to printf, and I'm going to print out this node. I'll do it with a space. And what am I printing? I'm printing current data. Okay, excellent. And if it's not equal to, if it's not an even number, then all I want to do is I want to move it along. Okay, I don't care about it. So I just want to move on to the next one, move to the next node. Okay, and voila. Okay, let's see what happens if we were to do this with our diagram. Okay, so we've got a list of 3, 4, 5, 6, and we want to see what happens if we do this code before we run it. Okay, great. So I've got a struct node current is equal to head. This is my head, and this is also my current now. Maybe I'll do it in a different color so it's more. Okay, this is now my current. Excellent. So whilst current next is not equal to null is my condition. So I'm going to check inside next. Next is a node, so it's not null. Excellent. I'm going to go into that while statement, and I'm going to check if current data, so is 3 divided by 2, does that give me remainders? It does. So I'm not going to go into the if statement, and that means I'm going to come out to line 256 and move current along. Okay, current is now over here. Excellent. Okay, so then I go back and I'll check, is current next not equal to null? So I'll go in here and check, is this node next to it? Is it equal to null? No, it's not. Fantastic. I'm going to go into this while loop and I'm going to check, is 4 modulus 2 equal to 0? Yes, it is, which means I'll go into this if statement and I'll print out the 4. So I'll print out a 4. Fantastic. Good. I'll come out and I'll increment my current to move on to over here. Okay, my current is now over here. I'll go back and check my statement. Is current next not equal to null? So I'm going to check in here. Is this node not equal to null? It's not. Fantastic. That means I'm going to go inside here and I'm going to check, is 5 modulus 2 equal to 0? No, it's not. So I won't go into this if statement, and I'll go to line 256 and I'll move my current along. So my current is now over here. I'll go back and I'll check, is current next not equal to null? Ah, it is, which means I'll come out of my while loop and finish this bit of code. And what that means is I have unfortunately missed out on seeing what's happening on my last node. Yeah. So in this case, I really want to be able to visit every single node. I really don't want to discriminate for my nodes. I want to be able to go to the last one as well to check if it's might be even as well. So in this case, I want to be going until current is not equal to null. And that means when I come out of the while loop, so when I come out of this while loop, the condition will be that current is equal to null. And that means I've visited every single node. Okay, let's try and run it now. I'll prototype it up top. Oh my gosh, how much code have we written? Jesus. Do that. Okay, and let's fill up. So we've got a 3, we've got a 4, we've got a 5. Anyway, there's an even number in there, and then we can see. Just going to get rid of it just in case I've. Okay, so we're going to call find even, and we're going to give it the head of the list. Okay, and save and compile and run. Okay, so my list is 5, 4, 3, 13, 8, and it's capturing the even numbers of 4 and 8. So in this case, the edge cases would have been to check that it's visiting the last node, and that's the one that can throw you. And then what else could be something that might break it? What else would we want to check just in case? And it might not break it, but we want to think about it and check it. What else do we reckon? Okay, let's see what happens if we have something at the head that's an even number. So let's insert an even number at the head and see if it works like that. So instead of this 5, I'm going to make it an even number. I've already got an 8. I'm going to make it a 6. Okay, let's try at the head. So I'll compile it and I'll run it again, and it doesn't. It's okay. It doesn't mind that at all. Okay. Anything else? What about if there's no even numbers at all? Do you think that will break it, or it won't do anything? What do we reckon? Okay, it's really annoying me that it's on the. What do we reckon? Hey? You should just freeze in that position, Ben. Just sit there for 2 hours like that. Yay, linked lists. I forgot what question I asked. Oh, if there's nothing, if there's no even numbers. Okay, let's try that out. If there's no even numbers, will it be okay? 5, 1. I think this was, I don't remember what this was. I think that's killing all the even numbers. Okay, let's compile it and let's run it. And it's just saying there is, yeah, it's not printing anything because there's no even numbers. So it's not going into that if statement. All right, so how was that? Was that a lot easier than deleting or inserting? Tom, thank you. Yes, easier, a lot easier.
Is that function like a struct function or a void?
Sorry?
Was that function a void or a struct?
So that function is a void because I'm just printing out, I'm not returning anything. Yeah, so because I'm not manipulating the list, which means I don't have to do anything. Usually when I'm manipulating the list, if I'm deleting something or I'm inserting something, because that means I might change the head of the list. That's when I consistently return something as well. Okay. All right. So I have another practice one, and it's a harder one, an insert harder one. But I think it's a good time to take a little break as well because it's 10:56. All right, so let's have a little break because because if we start the next one, we're stuck on the next one. And let's come back in at 11:05. Yeah, do you remember? It's because it had the overlay.
Yeah.
It needed a white. Oh, I'm not mute. All right, let's come back to this, and we're going to start with a Kahoot. No, wait a few more minutes, and then we will commence. It is really windy today, I agree. It is horrific outside.
Torrential downpour and then.
When was the downpour?
Last week.
Oh, yeah. All right. Shall we start? Let's start. Start them easy. Pumping music.
The most horrible thing is when the music doesn't play and you've just got silence.
Oh, silence.
That's horrifying.
We did have that happen once. Oh, very good. Almost. So remember that an array, when you get some memory for an array, it's arranged at compile time and you've got to specify a size. So if you say, I want an array of 1,000 because I'm going to be safe, then you get a memory piece that can store 1,000 of whatever you want, and you can't really change that. Whereas a linked list, you create nodes as you need them. So it's much better for dynamic sizing. Okay. It's very fitting that a current pointer is leading the scoreboard. Okay.
When I listen to it happen.
I should have like 2 dancers
Yeah.
here. Just
Yeah.
are you volunteering then? Okay,
well, Ben
almost.
was just telling me.
So a node and a linked list, remember our struct node, it's got some int data, and then it's got a struct node next, which is the pointer to the next item. It could have other things in it, as you can see in your assignment, but it is a node if it's got the next thing in it. It stores some data. Okay, here we go. I really like the 3, 4, 5, 6 list. I was a bit mean in that one because it printed out the current next data. So for those of you, yep, we'll go through it after I can see the piece of code again. Okay, let's see how everyone's gone. Lame list, no, they're not lame. We'll go through those. I'll bring up the things and we'll go through them. Quite change. Here we go. Last one. You'll never be able to look at 3, 4, 5, 6 the same way again. Very, it's all the feels, this music. Now it feels a bit like I'm at the ballet. Ooh. Okay, let's have a look and then we'll go through those pieces of code. I didn't see a single person in here draw a diagram. Someone's hungry. Okay. Ah. The letter M. Amazing. All right, let's run through. How do I just view this piece of code? It's like this. Okay, so let's have a look at this piece of code and let's quickly run through it. Okay, so we've got a struct node current, it's equal to head. Oh, I should have the, oh. Oh my God. Okay. Okay, so let's have a look here. Okay, so here we go. We've got our list 3, 4, 5, 6, and we've got a struct node current on line 2 is equal to head, which means that I have said that my current is currently pointing to the head. And then I've said that I is equal to 0. Okay, whilst current next is not equal to null, so whilst my current next is not equal to null, it's not equal to null, excellent. I'm going to go into the while statement. If I is equal to 2, I does not equal to 2, so I'm going to skip that. I'm going to increase I, and then I'm going to move my current along by 1. So my current is going to go from here, it's now going to go into here. Okay, I'll check again. Is current next equal to null? So, current next, which is this node, is not equal to null, so I'll go into the if statement. Is I equal to 2? No, it's not. So I'll skip the if statement. I'll increase the I, so I is now 2. And I'll move my current along. So now I'll move my current along. My current is now sitting over here. Okay, great. I'm going to check, is current next equal to null? No, it's not. Excellent. I'm going to go inside here. If I is equal to 2, is I equal to 2? Yes, it is. That means I'm going to go inside this statement and I'm going to print out a %d and I'm going to print out current next data. So current is this one, next is this node, and data is this. So I'm going to print out a 6. And then I'm going to increase the I, and I'm going to move the current along, Excellent. And when I move the current along, then I'll check, is current next equal to null? Yes, it is. So I'm going to finish up there. So it would have printed a 6. Okay, let's look at the next one. Okay, same list, but different, some sort of different story. Let me just get rid of these. Okay, so struct node current is equal to head. You're probably getting, dreaming of this now. Whilst current next is not equal to null, so whilst current next is not equal to null, this one's not equals to null, so I'm going to move the current along. Okay, check again, is current next, is this one equal to null? No, it's not, so I'm going to move the current along. Excellent. I'm going to check again, is current next equal to null? No, it's not, so I'll move the current along. Is current next equal to null? Yes, it is. So now I'm going to be up to line 8. And that means my current is sitting over here. And I'm going to struct node, new node malloc. So what it means is I'm going to malloc create a new node. And I'm going to give it the size of a struct node. So I'm going to create space for my node. And I'm going to assign, this is my new node, I'm going to assign 13 to the data. And I'm going to assign new node next. So into the next part of it, I'm going to assign the current next. So if I'm standing here, my current next is null, which means that null is going to go in here on line 10. And then I'm going to say current next. So that means that this part here is going to now point to the new node. So it's going to insert at the end. So the list is just going to be 3, 4, 5, 6, and then 13, and then onto the null. So it inserted at the tail. And then the last one, let me erase all of that. Okay, so we've got struct node current is equal to head. So current is going to go in here. And previous is equal to null. So previous is going to be somewhere here floating, and it's equal to null right now. Okay, and then we're going to go into our while. Whilst current next is not equal to null. So what it means is current next, I'm in here, so I've gone to this node, and then next again. So whilst this is not equal to null. Is this equal to null? No, it's not. So I'm going to go in here and I'm going to move it along, which means that my previous is now going to be in this position. And my current is going to move up by 1 as well. So my current is going to be in here. I'm going to go back and I'm going to check again. Is current next? So current next. Is it not equal to null? It is equal to null. So that means I'm going to come out of here and I'm going to say previous next. So the previous is over here. What's this arrow? Did I forget to put a current down? Who was keeping track? No, this, okay. So previous next is equal to current next. So that means that this is now going to point over here. And I'm going to free the current. I'm going to get rid of this one. So now this list is going to be 3, 5, and 6. Yeah? It just got confusing because of the next, which was the point of it. Okay. Excellent. All right, let's do problem number 3 in that case. We've done the even numbers. Let's do this one. Okay, or should we do multi-files? Oh, I just don't know what to do. Multi-files? Or do another linked list? How are we feeling? How are we feeling in here? Are we tired of linked lists? Do we want a little break from linked lists? Is everyone over current next?
Hands up though.
Yeah, hands up though.
Hands up for linked lists. Do more linked lists.
More linked. Everyone wants linked lists. Okay.
Hands up for something more different.
Oh, I'm sorry. Okay, I'm gonna try and do both.
Great.
No, well, it's 11:22. I think I might be able to. Maybe not. Maybe yes. If not, then on Monday next week we're gonna have because we're going to have Sophia answering questions in the seminar room, perhaps, and then I will be doing a big program that will also have more linked list stuff with actual context and stuff. And then on the Wednesday next week, I'll go through kind of like exam stuff, and then week 10 is going to be all exam revision and preparation. So, and I hope to run them with a few tutors around as well so that they can move through and help people as well. Why not? We're in person. We might as well have fun. Okay, so given a list, no, given some numbers, oh my gosh, I shouldn't write things late at night. Given some numbers, insert them in ascending order into a linked list. So given a number is what I was trying to say. Given a number, insert it into the list in an ordered fashion. So what I was trying to say, if the list is 3, 6, I'm just rearranging the list. I don't really want to do that. That's a really hard question to do right now. I'm gonna, I'm paining myself with this question that I thought of at 1 o'clock in the morning. I'm going to change the question because this one is going to give pain, so much pain. Where is, here it is. Okay, this is going to be our question. Someone is very confident in the chat that there are no more linked lists. I'm sorry. It's going to be a very long few weeks of just 1 week of linked lists. Then week 10 is revision of arrays and linked lists. You see, people said they didn't like arrays, but now that you feel differently. Okay, let's do this question. I want to, given a sorted list, okay, which is sorted from smallest to largest, I'm going to be given a number, insert the number into the list. So it's still sorted. Right? So so let's say you've got given the list 4, look at me changing it up, 4, 5, 6. I'm going to go 4, 5, 8. Null, and insert 7 would return the list 4, 5, 7 because 5 is greater than, 7 is greater than 5, 8, and then null. Okay. What would be the input? I'm going to write it in capitals so that you know where it starts and what would be the output. So if I'm inserting into a list, what do you think will be the input and what do you think will be the output? Yep, so I'm going to give it the head. I'm going to output the head as well. And I'm going to give it number to insert perhaps. Yep. Yep. Okay, so I'm returning the head, so struct node pointer, and I'm going to call it insert in order. And I'm giving it a struct node head, and I'm giving it some sort of data to insert. But the list that I'm going to be getting is a sorted list. Otherwise, this is not going to work in this case. Okay, so first steps first, I want to be able to move through the list. So I'm going to struct node current is equal to head. And if I'm going to insert in order, we can try it like this, and then we can see if we need something else here. Okay, so maybe let's draw a diagram and run through the steps, which is what I keep telling you to do. So the list is 4, 5, 8. Let's have a look. Okay, so our list is 4, 5, and 8. And I'm going to, this is the head of the list. This is going to be my current. And let's say I want to insert this number 7 in with the head of the list. Okay, I know that I will then need to insert it in here. So I'll need to have, if this is my current, I will need to malloc a node. So I will need to create this node that's got the 7 in it, and I'm going to need to insert it. So I'm going to need to travel alongst my list, and I'm going to need to travel until what? What do you think will be the condition that I need to travel until? How will I know I've reached there? So I can say until, 5 is less than 7. That's great. But 4 is less than 7 as well. So it still hasn't helped me. So I'll really need to go until the number here is going to be greater than the number that I want to insert. And then I'll insert right before it because the list is sorted. So that means I also, if I have to go to this node to check, that means, and this would be the current, but I need to insert before it. That means I want to keep track of my previous node as well in this case. So let's keep track of the previous node as well. So struct node previous is equal to null. Okay, excellent. Now, someone's got in the chat, yeah, so someone was moving along with current next, which is something else that you can do, absolutely. Okay, so what do you think, how will we move through this list? The same way we always move through the list, but do you think we will visit every single node, or do you think we will stop at the last node? What do we think in this case we would need to do? Would we go to every single node, or would we go past it and stop at null? What do we reckon? All the way? Stop before the last one. So you reckon current next. That means I will not visit this 8.
We have to check the value if it's greater than 7 or not. If it's less than 7, then perfect. If it's greater than 7, then it will stop before it and it's going to print at that point.
Yep. Yep. So I want to make my way all the way through the list. Yeah. Yeah. We can try both. So because if you go past the 8, if you stop and you don't visit the 8, then you're not going to be able to do anything inside the condition. So you will need to go all the way to null, because the previous one, that might be where you will insert it, or it might not work. We'll see. So let's go and try one of them, and then we can see how it works with our code. So if current, I'm going to go with what you suggested, just because why not? Okay, so if current next is not equal to null, okay, and what's going to be my next condition? Because I want to find a place, I want to keep going until my current node is greater than what I want to insert. Sorry, I want to keep going whilst it's less than. So I'm going to keep going whilst current data is less than whatever the data is that I've given it. Okay, so I'll keep going and moving through the list. So what that means is whilst 4 is less than, I'm going to go to the next one. Whilst 5 is less than, I'm going to go to the next one. And then I'm going to check, okay, is this greater or not? Okay, so what this means is that we're going to keep going. So inside here, inside this statement, we're not at the right node yet. We just want to traverse. Okay, so if we're moving through the list, what we're going to do is we're going to set the previous to the current, and then we're going to move the current one along as well. So current will be current next. Okay, so that means that when we exit this while loop out here, okay, so if we've used this condition, so that means that outside of this while loop, either my current next is equal to null, which means I am sitting on the last node, okay, or my current data is equal to or greater than data. So that's what happens when I've exited out of here. Okay, now I really want to know if this condition over here is true, but at this point I'm going to create my node that I'm going to insert, and I'm going to check for that condition. So let's create our new node. So struct node, new node that we're going to insert. I forgot to make it a pointer. Struct node new node is equal to what was the function called that we created? Create node, and what were we giving it? Which order? This is getting very, very messy. Where is the create node? Here it is. I'm giving it the data first, then the address. Okay, I'm calling that create node function, and I'm giving it the data first and then the address. So data first and then the address. Okay, so I'm giving it the data that I wanted inserted, and I'm giving it the address of where I want to insert it into. Okay, what do you think is the address that I'm going to give it? If I've created this new node here, where do I want to point that new node? And if this, where was I up to? This is going to be, so I've exited out of here. So that means my current is either, so if we run through the code to see where we're at, okay, we've got our current is head, previous is null. And oh, you can't see what I'm writing. That's unhelpful. Previous is null. Okay, and then we want to move through. Okay, so this is what we've done so far, and let's see if it's going to work. If current next is not equal to null, so I'm going to check, is current next not equals to null? So is this not, nope, good. And is current data less than data? So my data is 7. And so is my current data is 4 less than 7? Yes, it is. So I'm going to go inside here, and I'm going to move previous to current. So that means my previous is going to go over here, and my current is going to shift 1 as well. So my current is going to go to over here. And then I'll check again, is current next not equal to null? That means this node, is it equal to null? No, it's not. And then is current data, so is 5 less than 7? Yes, it is. So I'm going to go in here again, and I'm going to move it along again. So I'm going to say this is previous, and now this one is current. Okay, so now I'm sitting at current over here. I'm going to go back into the while statement. Is current next not equal to null? No, well, it is equal to null, so I'm going to exit out of here, and I'm going to go up to here. So that means my current is currently over here, my previous is over here, and this node that I want to insert, I want to insert it over here. So what is the address of this new node that I'm going to need to put it into? Oh, I see someone's done it in the chat too. Okay, so what's going to be the address of if I'm inserting in here? What do we reckon? I've inserted it in here, which means what I want to happen is I want this node to connect to this one and this node to connect to this one. So I want my new node to have the address of this previous next to point to this node. Okay, so I'm going to give it the address of previous next, which will point me to the right node. Okay, great. And what will I do now? Has that inserted it? Hasn't quite inserted it yet. So I've created the new node and I've linked it to the, so what I've created right now is I've created this, where it's got the arrow going like that. So it's pointing out to here, but my previous next is not yet connected to my new node. So how will I do that? What do we reckon? Said it out loud. Go on. Almost, someone said it's current next, but my current is actually standing over here. This is my current over here right now, which means if I make my current next new node, you're going to create the link that's going to go from here to here, which is not what I want to do. Yeah, so I want my new node, previous next, to go to new node. Okay, great. So my previous next, now going to go to my new node. Yep, that's it. Okay. It is going to break, by the way, a few times, but we're going to check when it breaks and when it doesn't. So I need to return something. I'm going to return the head. Okay, let's see it running, breaking. Why not? Okay, where are we at? Now let me create an ordered list now. I'll create this list here. So it's going to be 4, 5, 8. And then I'm going to use this new function, insert in order. I'm going to give it the head and insert the number 7. And then I'm going to print the list again so we can see if it's doing it or not. All right, let's see what happens. Compile, run. Okay, I've got 4, 5, 8 is the list and it's inserted it in the right position. Amazing. How can I break it? I'd like to break it. What do we reckon? What's some things that we want to try to break it? Go on. 5 conditions or 4 conditions that you always check for. What should we check? Where should we go? Where should we take it? How will I break it?
Negative numbers?
Negative numbers? Oof. It will have the desired effect of what I want to do. So that's, I like that. Okay, let's try it. Okay, -7. Okay, let's give it a whirl. Okay, so where does that mean we're inserting if it's -7? At the head, yep. All right, so again, you check inserting or deleting at the head, because the head and the tail and an empty list, that's what usually will break you. Okay, so what happened is it tried to create a node, and what I gave it is I gave it this previous next. But my previous is in fact equals to null if I'm inserting at the head, which means that I'm dereferencing a null pointer yet again, which is definitely not something I want to do. So I really need to be able to kind of counter that and make sure that, you know, everything is all right. So if I'm inserting at the head, it's going to be a very specific condition. So where would we do that? What do we reckon? Okay, so right now, we've come out, we great, everything is fantastic. Then we get to over here and we fail because this previous is equal to null. So when you try and do previous next, you're going to be in trouble. So what do we reckon? How can we combat that? I could do it over here, yeah, just before I create this new node, and I can check if previous is equal to null. Or I could do it at the beginning and check. Okay, so if previous is equal to null, then what do I want to do? That means that I'm inserting at the head of the list. Okay, so if previous is equal to null, I'm inserting right here. So that -7 is going to go in here. So what does that mean for me? If I want to have a -7 now, I want it to go in here. So what will happen right now? Previous is equal to null. Current is sitting at the head. So current is over here. Current is over here as we set it at the beginning. Okay, so how will I insert it? What will I change? What do we reckon? Everyone's just dying a little bit. I can feel it. Oh, it's giving me the, oh. Yeah. So you really want that new node to be the head, which is, yeah, but I don't have a new node right now. But if previous is equal to null, I can do some magic in there. Or there's another way I can do it. So there's a few, yeah. So I really just, what I want to be having is that head is going to be equal to my new node. But I haven't created the new node yet in here. So it's going to be a little bit of a problem for me. I can just create it in here if you want. What do we reckon? What do we reckon? Oh my God, everyone's dying slowly. I think I need a nap after this. Previous is equal to current. So if my previous is equal to null, then you are saying I want my previous to equal to current, which means that what will happen is that the previous will go over here. But what it will mean is that previous next, it will now take this over here. So you're not going to insert in the right place if you do that. How else can you check it? What do we reckon? No? Okay, let's have a look at the diagram again if it helps us. Okay, so if we have this as the next, we're sitting at previous is equal to null. We want to insert in here. So we've come out of this while loop, and currently, let's say it's not this condition. This is the condition that is stopping me. So my current data, so the -7 is, my current data, so this number 4 is greater than the data that I've given it. So that means I want to insert just at the head. So I want to create this new node, and then I want to pop it in here at the new head. Okay, so if the previous is equal to null, then I want to create the new node. And insert it at the head. Okay, so let's do that. Okay, we'll create the new node, struct node, new node. And there is a more efficient way to do this, but we will talk about that as well. But seeing as I've gone down this way, it's now happening like this. So we'll create the new node, we'll give it data, and then what do we want to give it? So remember that we're currently sitting over here. This is my current. So that means I really want to give it the address of current because I want to link this node to then point to current. So I'm going to give it that, and I'm going to give it the address of current. And then I'm going to say that my new head is going to be equal to the new node, which has connected me, which has moved the head along to the new node, and the new node is now pointing to that one. And then I'm going to return head. Let's see if that will save us or not. Run. Okay, and so now it's inserted it in because we've kind of captured that, what happens at that null situation. Okay, what is something else that might break this piece of code? So we've tried the head, it broke it. What else is going to break it? What else might break it? Should we try inserting at the tail? Let's try inserting at the tail and see if that works. So let's do an insert of a larger number than 8 and see if that's going to give us what we want. So let's insert a 20.
What about a character?
Oh, that will, yeah, that will not go well. Okay, 20, what a disaster.
The current data, our current next is no value here.
Exactly. And that's because in our while loop, we've been going until current, oh my gosh, where is it? There we go. Current next is not equal to null. So we're not going to that last node. So we really want to go to the last node. We don't want to avoid it. So let's see if that solves our issue. Let's try it. Beautiful. So now it's inserting right at the end because it's visited the last node. Okay, great. And then someone said insert a character. That will absolutely break it because it's expecting an int, and we're not safeguarding for it. So we're not doing the error checking that because we're kind of hard doing it right now. But if you scan in user input, for example, what number do you want to insert, then you can check that they've given you a number. Yeah.
What happens if we include the 7 again now that we sort of like gone back? We want to create the
Oh, okay. So now insert the 7.
like what we did for 20 that worked. Like with this, like this what happens if we go back to 7 with that.
I see what you're saying. Yeah. So will the 7 like that? Okay, it will be fine because we've taken care of that middle case. And so these are the ones where we're checking that we're still doing things at the head and at the tail perfectly. Okay, and what happens if I've got an empty list? Do we check that? We should always check that. So I'm going to get rid of anything. It's an empty list now. And then I'm going to try and insert into the empty list. And let's see if that works for us. Let's run it. And it has, okay? And the reason it has inserted into the empty list is because of that safeguard that we did before. We've safeguarded for previous is equal to null. We've told it what to do. And current next is equal to null. So it's working fine for that. And then someone has said data value greater than the tail node data. Yeah, I mean, we can. I think we did that with 20, so that was okay. That worked okay. Anything else? What if we put in 4? Ah, a duplicate. Nice, very nice. Yes. Let's see what it does. Oh, I have an empty list. That's not going to be what I want it to do. So in your exam, I want you to like imprint, check at the head, check at the tail, check an empty list. And then, you know, try those 3 things because they're the things that will hurt your code. Okay, so it will insert the duplicate because we're checking, our condition for checking is that it's equal to, I think. So it will capture that. Oh, it's just less than. So when we come out, it's either equal to or greater than, and it will capture the duplicate. Yeah, so really you want to check the head, the tail, the middle just for your average case, and finally an empty list. And that's always check those. And really when you're doing arrays, it's the same thing. Check what happens at the first index, at the last index. Is it still working in the middle? Those are the boundaries always. Auto tests are available in the final exam. You will not be left on your own, but they will reduce in number as you move up the questions. So the first 4 questions will hold your hand and cradle you, and then the rest will not as much. They will just gently pat you, but not that gently. I don't know. Yeah, well, it's I'm rewriting half the exam because I decided it's too hard though. So at least something. How many questions are there? Everyone loves talking about the exam. We will have a beautiful conversation about the exam for like an hour next week on Wednesday. There's 7 questions and 20 short answer. Will you be given the idea of how? Yes, you will be given a practice exam in week 10. You will not, and it will look exactly the same as the final exam, but not exactly the same, obviously. It will be similar to the final exam, but it will be in the environment that your final exam is in. So you will get a feel for what is going to happen on the day. And the day is a little bit weird because it's our first in person in quite a few years. So you'll be corralled. You'll be locked in a room for 30 minutes, so you can't pass information to each other. And you'll have slightly different exams. Is there multiple choice? There's like a few multiple choice, but they're like short answer. Auto test for the short answer question. No, I'm sorry. No auto test for the short answer. Come on. Nice question. Nice try. All right, we're going to finish there for today. I think looking out at the people in this theatre, everyone is looking, God, I've killed your Wednesday. But draw a diagram. You see how many mistakes we picked up just by drawing a diagram and trying to actually run through the code in the diagram. It really makes a huge difference. And don't be worried. You will often find mistakes as you write the first chunk of code. Something will go wrong at the head, at the tail, or at an empty list, and then you can kind of counter for it. And draw the diagram because then you can see who needs to relate to whom. Anyway, I hope you have a good rest of the week. There is revision classes running this week, so sign up for those if you want to. If you need any help in the course, if you're feeling that you are struggling a little bit, please send me an email and we can organize other things for you to try and get you over the line and help you through the next few weeks. Help sessions are going to ramp up in weeks 9 and 10 to help you through your assignment 2. And then on Monday next week, we're going to do a lecture program that's going to look a little bit like the assignment, really, a very short version of the assignment. Okay, don't worry about multi-files. We'll do them later. And if you have any feedback from today, or if there's anything that you would like to cover in particular next week, pop it in the feedback so that I can see and we can do that. Are there going to be links shared for the revision in Ed? Yes, there's going to be, don't worry, there's going to be a lot of revision, and we're going to have more revision classes running in week 11 as well, so that if you want to come and practice for the exam, you can. but you don't have to, but you can. And what else are we running? There's more things that we're running. More information is coming. There's a lot more things running. But good luck. Have a good rest of the week. I look forward to seeing you on Monday in seminar room 113. And yep, peace out. Have a good week.